Today, today I want to discuss about the analytic function and its property. First, what do you mean by analytic function? Suppose first we have to discuss what do you mean by analytic function. Suppose a function f of z equal, equal to u of xy plus I v of xy is said to be analytic in a domain D. Domain is in a complex domain D if if it satisfies if it if it satisfies if it satisfies the del u by del x equal to del v by del y and del v by del x equal to minus del u by del y. And basically this is called as CR equation, CR equation or Cauchy-Riemann equation. So basically a function f of z is analytic is is analytic everywhere analytic everywhere in a complex plane then it, then f of z is called as entire function. So an entire function means it is analytic everywhere. So now we have to correlate analytic function with respect to holomorphic function. Holomorphic function. A function a function f of z is said to be holomorphic if holomorphic at a point z naught if it is complex differentiable if it is complex differentiable at z naught. So that means every holomorphic function is analytic. If a function is holomorphic, then we can say it is analytic. Next, another point, and a very important point, is suppose f of z equal to u of xy plus I v of xy. This point is very important for exam point of view. Uh, is analytic means analytic function, then its real part, it is a real part, this one is called imaginary part, then its real part and imaginary part satisfy the Laplace equation. If a function is analytic, then its real part and imaginary part satisfy the Laplace equation. Satisfy the Laplace equation. Is very important for GET and UGC NET exam. So using this concept, we have to solve this 3-mark question. That is CSR NET 2011 question. Here, this function is given. Here, f of z is given. F of z is given. So v of xy equal to 3xy square. Then f cannot be holomorphic on C. F is holomorphic on C. So we have here every part is associated with the holomorphic. That means we have to check whether fz is analytic or not. If fz equal u of xy plus I v of xy, then its corresponding real part and the imaginary part must satisfy the Laplace equation. Here v of xy given, that means imaginary part is given. We have to check whether this imaginary part satisfies the Laplace equation or not. If it satisfies, then we can tell this is analytic or holomorphic, analytic or holomorphic. So first we have to check whether v of xy, whether v of xy equal to 3x y square satisfy the Laplace equation or not. So what is the condition? V satisfy Laplace equation means we have to prove whether del square v by del of x square plus del square v by del of y square equal to 0 or not. If it is 0, then satisfied. If it is not equal to 0, then not satisfied. Next, we calculate the derivative of this function del v by del x equal to how much? So partial derivative of this function del by del x of 3x y square. So here, so this one take out 3y take out, so 3y square del by del x of x, so which equal to 3y square. Now del square v by del of x square, which equal to del by del x into del v by del x, so which equal to del by del x. This value is 3y square, which equal to 0. Now same way we calculate del v by del y, which equal to del by del y. V is given as 3x y square, so which equal to 3x take constant del by del y of y square. So this derivative equal to 3x 2y, that is 6xy. Next take the derivative. Next take the derivative del square v by del of y square, which equal how much? So this equal to del by del y of this 6xy, so which equal how much? 6x. Okay, so 6x. So now adding these two, now get now adding these two result, whether this result is 0 or not. If it is 0, then it is satisfied. If not 0, then not satisfied. So now del square by del of x square plus del square v by del of y square equal to 0 or not. This part will be 0, this one will be 0, just substitute, plus 6x, so which equal to 6x not equal to 0. So if it is not equal to 0, it indicates what? So if it is not equal to 0, so V is not associated in any imaginary parts of a analytic function. That means whatever the value of u, so v does not obey the analytic Laplace equation. So it is not analytic. F of z is not analytic. So not analytic means not it cannot be holomorphic. So next this part will be this solution will be now. Okay. Now, my next point is in part 3, most of the question associated with this singularity and residue calculation. So, first we have to discuss singularity. So, what do you mean by singularity? So, singularity, suppose a complex function f of z is given as 1 by z minus 5. So, if you put z equal to 5, f of z is not defined. If you put z equal to 5, 1 by 5 minus 5, so it's infinitive. So that means if you put z equal to 5, f of z is not defined. So z equal to 5 is a singular point. So singular point means it is at that point the function is not defined. Basically, in complex analysis, singularity can be classified as three types. First one is removable singularity. Second one is fourth, and third one is essential. Third one is essential singularity. Singularity are of three types: removable, fourth, and essential singularity. So we have to explain what the three types of singularity with respect to concept of limit. Suppose, suppose f of z having its singular having the singularity at z equal to z naught for 4 limit z tends to z naught f of z equal to infinity. This is one case. For removable singularity, limit z tends to z naught f of z is finite. Means it has some values which finite. Removable singularity. Next, go for essential singularity. For essential singularity, limit z tends to z naught f of z does not exist. Does not exist. With this concept, we solve some more problem regarding on singularity. Go for these questions. Here, this function f of z is given. So we have to check z equal to 0, which type of singularity it is. First, we have to check whether z equal to 0, this function is defined or not. So if you put z equal to 0 in the denominator, e to the power 0 is 1, 1 minus 1 will be 0. That means this function is not defined at z equal to 0. So z equal to 0 is a singular point. Okay. If z equal to 0 is a singular point, next to go for calculation. We have which type of singularity we take. First we calculate limit z tends to 0 f of z. This value will be how much? So which is equal to limit z tends to 0 e to the power 0 plus 1 divided by e to the power 0 minus 1. So if this limit equal to how much equal to 0? This limit will be infinite. If z equal z, this limit will be infinite. So infinity means so z equal to 0 is a pole. First, so it is next you have to check other options are correct or not because this in this question number 2 more than one option is correct. So we check. So removable singularity is not it is in one singularity is pole, so it's not so it cannot be removable singularity. It cannot be essential singularity. Next, we have to check whether the option B is right or wrong. So first z equal to 0 is a simple 0 means it is simple 0. So we have to calculate the residue of this function, residue of f of z at z equal to 0. So here z equal to 0 is a order 1. We have to explain why order 1 in next article. So here we calculate limit z tends to 0, simple 0, z minus 0. This is the formula for calculation of the residue at simple 4 e to the power z plus 1 divided by e to the power z minus 1. So which equal to limit z tends to 0 e to the power z plus 1 divided by e to the power z minus 1 into z. So we calculate this limit. So which equal to limit z tends to 0 z z multiply plus z divided by e to the power z minus 1. So to put z equal to 0 here. So numerator is 0, denominator will be 0. That is 0 by 0. If it is 0 by 0 4, then we have to use the concept of L-Hospital rule for calculation. Limit z tends to 0. L-Hospital rule means take the derivative and derivative numerator and denominator with respect to z. That means d by dz of by apply L-Hospital z e to the power z plus z divided by d by dz of e to the power z minus 1. And this one is equal to limit z tends to 0. So by product here z e to the power z plus e to the power z. Here we apply the product rule. Z z zero derivative is 1. Here e to the power z derivative is minus 1 derivative is 0. So put z equal to 0. So we get e to the power 0 plus 1. That is 1 plus 1, that is 2. So the ratio is 2. So these two options are correct for this question. Okay. So this question is carrying it takes 4.75 marks. If you are correct, so you get 4.75 marks. Okay, go for next. So this question is given. We have to solve which type of singularity. The first exponential e. So you have to remember very important concept. E to the power x can be written as e exponential of x. Okay. So here this function is given. So you have to check which type of singularity it is. Put z equal to 0. So denominate z by this denominator is 0. So z equal to 0 is a z equal to 0 is a singular point. So if z equal to 0 is a singular point, next we have to check which type of singularity it is. So for singularity, we go for the concept of limit. So using the concept of limit, so we calculate limit z tends to 0 f of z. So which equal to limit z tends to 0. So here we write exponential of e to the power z by 1 minus cos z. So which can be written as e to the exponential e of p of limit z tends to 0 z by 1 minus cos z. Question added how it is. So suppose simply how this. So we have to explain. Suppose we calculate limit extends to 2 e to the power x is how much? Which equal e limit x tends to 2x, so which equal to square. By simply this concept we extend the exponential and limit. So which equal to um, exponential of put your numerator and denominator is the 0 by 0 form. So we take L-Hospital rule here, limit z tends to 0, L-Hospital rule apply, z derivative with respect to z is derivative with respect to z is 1. So here 1 derivative is 0, cos z derivative is minus sin z. So which equal to minus into minus, that is sin z. So if you put which equal to e to the power infinity. So e to the power infinity means does not exist. E to the power infinity value really does not exist. So does not does not exist. If the limit does not exist, what does which type of singularity? It is called essential singularity. If the limit does not exist, then it is called essential singularity. Next, so if once essential singularity conferred, then pole and the remaining content is removed. This the option is removed. Next, we have to check whether the option B is right or wrong. So option B means we have to expand this function. We have to expand this function. So how we can expand it? We have to expand this function. So all of you know the expansion form of e to the power x is equal to 1 plus x plus x squared by 2 factorial like this. So here it is given that exponential of z by 1 minus it is given that 1 minus cos z. 1 minus cos z, we have to expand this function and we have to take whether it contains infinitely many powers of z or not. So we have to expand by this concept. So which equal to how much? E to the power x which equal to 1, 1 plus in place of x this function present, we write z by 1 minus cos z plus x square 1 by 2 factorial x square. Again, we assume this part is x. So which equal to z by 1 minus cos 0 whole square. Dot dot. This one is given. So now we have to expand 1 plus z by 1 minus cos z expansion is 1 minus z square by 2 factorial plus z fourth by 4 factorial like this. Similarly for this, so here it contains negative this positive as well as negative power of z infinite. So if you calculate both of the solution parts, current expansion contains infinitely positive and negative power of z. This one is also correct. So just to remember a condition. So if removing it, take binomial expansion that is minus. So if you expand it to the z contains both positive infinite number of positive parts and negative power of z. So positive and negative power of z is infinite number. That is the option B is also correct. Suppose any unknown function fx is given, how to find its expansion? So which equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0. Using this concept, we have to find the expansion form of any unknown function. Okay? So thank you. Here, this one is to the topic. Next article, I will explain more questions regarding an analytic function and the application. Thank you.